Hi guys, this is lesson 6 in unit 2. We're going to talk about compound inequalities. So the word compound means two together at the same time, or two inequalities together at the same time. So if we take a look at our first example, we have an inequality that includes numbers in between -8 and 2. I'm not including -8, I'm not including 2, and the only thing I'm including in this solution set are the numbers in between -8 and 2. So to write this inequality, I have to break it into two parts. The first part is where I write down the values that are less than 2. And the second part is to identify the values that are greater than -8. But at the same time, the values in this compound inequality has to satisfy both inequalities. That means the solutions that I'm including in this inequalities are every single number greater than -8 and less than 2. So I'm going to put these two inequalities together in one compound inequality by having x in the middle, and then this x has to be greater than -8 if we read the inequality from right to left, and this x has to be less than 2 if we read it from left to right. Now let's take a look at the second example where we have an inequality or a compound inequality, and in this compound inequality we're including every single number greater than 5, and we're including every single number less than -1. So again, I'm going to break this compound inequality into two parts. The first part is x is less than -1. The second part is x is greater or equal to 5. I know that the solutions for this compound inequality has to be either less than -1 or less than or greater to 5. So to write this compound inequality, I'm going to have x in the middle, and I'm going to identify that this value in this compound inequality has to be greater or equal to 5 if you read it from right to left, and it has to be less than -2 if you read it from left to right. So how do we solve compound inequalities? We solve compound inequalities the same way we solve inequalities. When solving a compound inequality, the goal is to have one variable, it could be x, it could be y, whatever the variable is, in the middle of the compound inequality, and solution at both ends of the inequality. And we're going to look at an example, and you'll see how this can apply. And then any property that you use to solve inequalities, you can use to solve compound inequalities. We talked about different properties. We talked about the distributive, commutative, associative property, and we talked about the addition property of inequality, the multiplicative property of inequality. All these properties can be used to solve compound inequalities as well. So let's solve our first example on compound inequality. We have -5 less than 2x plus 1 less than 3. The goal here in this compound inequality is to have x here in the middle by itself, which means I need to get rid of 1 and 2. You remember, guys, from solving equations that to have x by itself, I need to get rid of 1 here in the middle, which means I'm going to have to subtract 1 from all sides. And this is the key thing in solving inequalities or compound inequalities. Whatever you do to one side, you do to all sides. So if I want to get rid of 1 in the middle of the inequality, I have to subtract 1 from all sides of this compound inequality. After that, I'm going to end up with -6 less than 2x less than 2. Again, my goal is to have x by itself, which means I need to get rid of 2. And to get rid of 2, I need to divide all sides by 2. When I divide all sides by 2, I end up with -3 less than x less than 1. And this is the solution for this compound inequality. This is the solution set for the compound inequality. All I need to do is to put the solution set on the number line. And I'm going to have to put 2 numbers on the number line. I'm going to have to put -3 right here. And then put 1 right here. And in this solution set, I'm not including -8. I'm not including 1, but I'm including every single number in between these two. So all I need to do is to include every single number between -3 and 1 to represent this solution set. So now we're going to learn how to represent an inequality using an interval notation. We learned how to represent an inequality on the number line, and today we're going to talk about interval notations. So let's take a look at our first example. We have x is greater or equal to 5, and to represent this inequality on the number line, we said we're going to have 5 in the middle of the number line, and then I'm including 5 in this inequality, and every single 5 greater, every single x, or number greater than 5, that's why I'm going to have an arrow to the right. I can represent this inequality using interval notation, which basically means you need to identify the starting point and the end point of the inequality. So my solution set, or my value, starts at 5. That's why I'm going to have brackets here, because I'm including 5. And it doesn't have an end. And when I don't have an end to my inequality because it's going to infinity, I'm going to have to put infinity here. And when I use infinity to represent an inequality, I need to use parentheses instead of brackets. Let's take a look at the second example. We have x is less or equal to -3. Again, we're going to represent -3 in the middle of the line right here. I know I'm including every single value that is equal to -3 or less than -3, which means my arrow is going to go to the left of the circle this time to represent all these numbers that are less than -3. So looking at this inequality and at this number line, my numbers do not start at a certain point. They're going to the left side of the number sign, number line, which is -infinity. So I'm gonna represent the starting point by a -infinity because I don't have a starting point for my inequality. But I have an end point. My numbers end at -3, including -3. So that's why I'm going to have -3 at the end of this interval with a bracket. Let's take a look at our next example. We have x is less than -20. So I'm going to have -20 here in the middle. I'm including every single number less than -20. So this time I'm not including negative 20. That's why I'm going to have an open circle right here, and I'm including every single number less than negative 20, which means I'm going to have to make an arrow to the left of the circle. Now, to put this in an interval notation, I know I don't have a starting point for my interval. My starting point is negative infinity in this case. And my numbers end at negative 20, but I'm not including negative 20. For that reason, I'm not going to use a bracket, I'm going to use parentheses, because parentheses represent that we're not including negative 20. Last example is x is greater than 1/2. Again, we have 1/2 here in the middle. I'm including every single number greater than 1/2, not including 1/2, so I'm going to have an open circle. And greater numbers are to the right of the circle. That's why I'm going to have an arrow to the right of the circle. And then to write this in an interval notation, my inequality starts at 1/2, but I'm not including 1/2. That's why I'm using parentheses. And then my inequality does not end at a certain number, so I'm going to have to use infinity to represent the endpoint of the inequality, and again with parentheses. So this is how we write inequalities in interval notations. Now let's write interval notations for compound inequalities. So our first example is x is greater or equal to 0, less than or equal to 5. That means my inequality is between the numbers of 0 and 5. So I'm going to represent 0 here at this side. 0, 1, 2, 3, 4, and 5 is going to be right here. So I'm including 0. That's why I'm going to have a closed circle. I'm including 5. That's why I'm going to have a closed circle. The inequality says that I need to include every single x is greater or equal to 0. That means this way. And at the same time, it's less than or equal to 5, which means my number line or my numbers are going to be between 0 and 5. And this is how we can graph this inequality on the number line. Now, to write this in an interval notation, I need to use a bracket to represent the starting point because I'm including 0. My inequality ends at 5, including 5. That's why I'm going to have a 5 and then bracket to represent this inequality. My second example is x is greater than negative 5, less than or equal to negative 3. Again, my inequality starts at negative 5. And this is negative 3 right here on the number line. I'm including every number greater than negative 5, but less than or equal to negative 3. That means I need to have an open circle for negative 5, a closed circle for negative 3, and then I'm including the numbers in between. Now, to represent this in an interval notation, I'm going to have, okay, let's finish the number line. I'm going to have a bracket or parentheses for negative 5 because I'm not including negative 5. And I'm going to include Negative 3, that's why my inequality ends at negative 3, and I'm going to use a bracket at this side to represent negative 3. My next example is x is less than negative 2 or x is greater than 0. So I have negative 2. I'm not including negative 2, that's an open circle. X is less than negative 2, that means all the numbers less than negative 2 to the left of the open circle. And then x is greater than 0. 0 is here. I'm not including 0, that's why I have an open circle. But I'm including every single number greater than 0, which means an arrow to the right of the 0. So to represent this inequality on the number line or in an interval notation, I know that I'm going to start my inequality with negative infinity, and then it ends at negative 2. Not including negative 2, that means I'm going to have a parentheses. And then, or, I'm going to use or, because the solution can be in one of these two inequalities. It could be in this interval where I have 0, not including 0, to infinity. Again, I'm using parentheses. Our next example is x is greater than 1 and x is less than or equal to negative 1. So this time I have negative 1 and 1 on the number line, so I'm going to represent negative 1 right here, 1 right here. Let's graph the first inequality. We have x is greater than 1. That means I'm not including 1, but I'm including every single x greater than 1. That's why I have the arrow to the right of 1. And then I have x is less than or equal to negative 1. So in this case, I'm going to have an open circle, or actually a closed circle, because I'm including negative 1. And then an arrow to the left of that circle for every single x less than negative 1. I have the word and, so I need to find the solution for this inequality, and I need to find the value that satisfies both inequalities in this compound inequality. And looking at these two inequalities on the number line, these two inequalities do not share any solutions together. And when we have the word and, that means that the solution should satisfy both inequalities. And since there is no value that satisfies both inequalities, there is no solution for this inequality. There is no value or x value that satisfy both of these two inequalities. No value that these two inequalities share together. So there is no solution for this inequality.